What's up, gang? This is Adam and Elowitz for Physics 2212 Lab 2 Lines of Charge. So a continuation of last week's lab. So introduction, our objective in this lab versus the other one is our goal is to use our data and results from last week's lab to produce a computational model in GlowScript of the two charged tapes and electrical force exerted. So using this model, we can estimate the amount of charge per tape that would be required to make them flow as observed. And so the fundamental principles we're going to use here is Newton's second law, F equals ma, Newton's third law of equal and opposite reactions, Coulomb's law, and the concept of superposition. These are important because with Newton's second law, we know how to calculate the forces. With Newton's third law, we know that the force of gravity must be equal and opposite to the force of electricity, which is how we're going to calculate our new Q. Coulomb's law is how we calculate that said field, and just like in lab 1, we're going to assume each piece of tape possesses the same charge evenly distributed across the length. And we'll also assume that each piece of U-tape can be divided into equal segments of equal length and charge, and that the total charge and field of U-tape is the sum of those segments, which is the concept of superposition. So the results came out to be that the charge on each piece of tape is 2.5164 times 10 to the negative 8 coulombs when using the line charge model in GlowScript versus our value from last lab, which was the charge on each piece of tape is 1.253 times 10 to the negative 8 coulombs in magnitude. And so we see this is a 100.83% increase over what was calculated in the original lab, and this is when Fg equals Fe. So just to recap, here's the diagram from our previous lab. The tape on the top is being repelled upward by tape on the bottom, and the distance between those two tapes is going to be 0.02921 meters. Each tape is 0.127 meters wide, 0.2113 meters long, and the mass of each piece is 0.16904 grams. Our fundamental Q value is 1.6 times 10 to the negative 19th for our magnitude of a single charge. Our K constant is 9 times 10 to the 9th, and our acceleration due to gravity is 9.8 meters per second squared. So here's our GlowScript code for the model, which I'll be walking you through right now. First off, we just need to set our physical concepts. We have our charge of all of our protons, we have our fundamental constant, our length of an atom, which is important later on, and our acceleration due to gravity, which is 9.81. We then have just other observed values. Not all these were used, but I put them in just in case beforehand, in case we didn't have means to use them. We have our separation, our mass, our length, and our width. The mass is right here, 0.0001694 kilograms. And then next we put the charge of one tape for the equal and opposite field. And so this is the value that we play around with, because once we make our original model, to start off with, I put my value in from my first one, which is 1.253 times 10 to the negative 8th, and then I later calculated this value to see what would be equal and opposite once I got what my gravitational field was. Next up, we have our function of electric field. So we have our R right here, our Q value is just the charge product without charge, and then we have our electric field equation. It's just everything put together in it, like the KQ over R max squared times R hat. So that's just plugging in the equation we learned from class. This function right here was given to us, and it creates our lines of charge for the equation. Next up, we created the tapes. So these are also given to us, just created two like bars of point charges representing the piece of tape and the fields coming from each of those. I then had my scale value for my arrows for the field. We wanted this to be pretty small because the arrows came up pretty big originally. Then this is the charge for each piece of tape, and this will create our arrows for our fields and calculate our force on the top and the bottom. And we'll now create arrows for the next electric force on tape right here. So this is for E force of gravitational, these two right here, and then it prints it out. And my link for my code is in my bio. What will you learn from that if you need it? So there's also, again, charge on one piece of tape came out to be 2.5164 times 10 to the negative 8 coulombs. Compared to our value from lab 1, which is 1.253 times 10 to the negative 8 coulombs, and necessarily it's 183% increase. And to find this value of 2.5164, I use this equation which we derived in class. So now we're just going to discuss the what and why questions for this lab. So first is, what if we had modeled the tape as a point charge instead? Had we done this, we would have gotten the results as we did last lab as opposed to this one, which is where the point charge value is 1.253 times 10 to the negative 8 coulombs, which we got last time, and the line charge is 2.5164 times 10 to the negative 8 coulombs, because last time we did not account for the charge coming from all over the rod, just one single field coming from the middle and one force coming from the middle. And these are different because, as I stated just a second ago, last time we only accounted for one line in the middle, versus this time we were taking the field from every single part along the rod, every single delta y. And so by taking the sum of those, like we did in this lab 2, we get a more accurate reading as it includes a charge along the entire rod. Thank you all so much, and have a great night.